Welcome everyone in the session of electrostatic potential and capacitance. Here we are starting to do some objective questions and the level 1 part. Let's begin with the electrostatic potential and potential energy. The first question we have: the potential difference between two plates separated by a distance of 1 millimeter is 100 volt. The force on an electron placed in between the plates is 10 to the power 5 Newton, 1.6 10 to the power minus 24 Newton, 1.6 10 to the power minus 14 Newton, 1.6 10 to the power minus 19 Newton. So let's see the solution for this question. We know the formula F is equals to EQ. E means V by D. How this V by D comes? So we know the electrostatic field is a negative gradient of a potential energy. And if we just take the mod of that, we get V by D. If I just put all these values, we get 1.6 10 to the power minus 14 Newton, which is option 3. Moving ahead with the next question, a sphere has a charge of a plus 50 coulomb. The absolute potential at a point at a distance of 10 to the power minus 12 meter from the sphere is 4500 volt, 45 10 to the power 23 volt, 4.5 10 to the power 23 volt, 4.5 10 to the power 24 volt. Let's move with the solution. So we know the formula of potential difference, which is V is equals to 1 by 4 pi epsilon naught Q by R. What is epsilon naught here? So epsilon naught is nothing but permittivity of free space. So the value of epsilon naught is 8.85 10 to the power minus 12 coulomb square per Newton meter square. If I just put all these particular numerical data, we get the value of 4.5 10 to the power 23 volt. According to this, the correct answer for this question is option 3rd. Next question we have: two charges of 10 microcoulomb and minus 20 microcoulomb are separated by a distance 20 centimeter. The distance of the point from a smaller charge where electric potential is 0, if it lies between them, is 3 by 20 centimeter, 6.67 centimeter, 10 centimeter, 16 centimeter. So let's move on the solution part. We know the formula X is equals to D Q2 by Q1 plus 1. We just put all these value up to here and get the result 6.67 centimeter. According to this, the correct option is option 2. Next question we have: A, B, C are 3 points on a circle of a radius 1 centimeter. These point from the corner of an equilateral triangle. A charge 2 coulomb is placed at the center of the circle. The work done in carrying a charge of 0.1 microcoulomb from A to B is 0, 18 10 to the power 11 joule, 1.8 10 to the power 11 joule, 54 10 to the power 11 joule. So, the solution which we have is sphere forms an equipotential surface. That means the difference between the potential is a 0. Next question we have: a potential energy of a proton is 3.2 10 to the power minus 18 joule. At a particular point, the electric potential at this point is 5 volt, 10 volt, 20 volt, 15 volt. The solution which we have: work done is equals to V into Q. How this will become? We know that voltage is equals to work done per unit charge. Similarly, if we just take out the value of W from here, we get this result. and the W is given 3.2 10 to the power minus 18. The Q is, we know, 1.6 10 to the power minus 19. This is for proton. After solving, we get 20. According to this, the correct option is option 3. We have another question. When n small drops are made up of combine to form a big drop, then the big drop's potential increases to n to the power 1 by third times of the original potential, and the charge density decreases to n to the power 1 by 3 times original charge. Second, we have potential increases to n to the power 2 by 3 times original potential, and the charge density increases to n to the power 1 by 3 times original charge density. Potential and charge density decrease to n to the power 1 by 3 times original values. And the last, we have potential and charge densities increases to n times original values. Let's see the solution. So conceptual, we know that V prime is equals to n to the power 2 by 3 times of a volume. According to this, the correct option which we have, option 2. Hope you understand. Next question we have. The potential between two plates separated by 1 millimeter is 1000 volt. The force on an electron placed between the plates is, options we have, 1.6 10 to the power minus 13 Newton, 1.6 10 to the power minus 19 Newton, 1.6 10 to the power minus 14 Newton, and the last 1.6 10 to the power minus 10 Newton. So the correct option is a 1. Let us see the solution of this question. We know that force is equals to E into Q. We just put this value and get the result, which is a 1.6 10 to the power minus 13 Newton. Next we have the work done in carrying a charge Q once round a circle of a radius r with a charge Q at the center is. We have these options. So let us move on the solution. Work done in moving charge on an equipotential surface is always to be 0. Hence, the correct option is 0. Next, we have the charges of 4 microcoulomb. Each are placed at the corner of A and B of an equilateral triangle ABC of side length 0.2 meter in air. The electric potential at C is 1 by 4 pi epsilon naught is equals to 9 10 to the power 9 is given as a hint. We have an options are these. Let us move with the solution part. We know that the value of V is equals to 2Q divided by 4 pi epsilon naught d. Now, we just put all these value and get the result, which is option 3. Hope you understand. Next, we have a question. A larger drop is made from the two smaller drops, each having 100 volt. Then voltage on a bigger drop is 100 volt, 1000 volt, 156 volt, 100 into 2 to the power 2 by 3 volt. Now the solution which we have, V prime we know n to the power 2 by 3 times V. So we just put this value and get the result according to this. The correct answer for this question is option 4. Next question we have, an identical mercury drops charge to the same potential V coalesces from a single bigger drop. The potential of the new drop will be V by N, NV, NV square, n to the power 2 by 3 times a V. Let us see the solution of this question. V prime is equals to N 2 by 3 times of a V. According to this, the correct option is option 4. Next we have a hollow metal sphere of a radius 5 cm is charged such that the potential on its surface is 10 volt. The electric field at the center of the sphere will be 15, 10, 5, 0. Move with the solution part. The electric field at the center of the sphere is 0 because charge resides on the outer surface of a sphere but not inside the sphere. That's why the correct answer for this question is option 4. Next we have the work done in carrying 20 coulomb charge through a distance of 5 meter is a 2 joule. The potential difference between these 2 points will be, we have few options, which these are. Now move ahead with the option solution. So we know that W is equals to V into Q. We just put this value and get the result according to this. The correct answer for this question is option 4. Next question which we have, an infinite number of the charges each equals to capital Q are placed along the x-axis. At x is equals to 1, x is equals to 2, x is equals to 4 and x is equals to 8. The potential at the point x is equals to 0 due to its set of charges. We have these options. Let us move with the solution part. So we know that V is equals to Q by 4 pi epsilon naught. Now this is in the given in this GP form. So we just use the formula for GP and get the result, which is option 2. Now the next question which we have, a point positive charge Q is carried from a point B to a point A in the electric field of a point charge capital Q. If the permittivity of free space is epsilon naught, the work done in the process is given by. We have these options. Move for the solution criteria. So we know that W is equals to Q by epsilon naught, Q by A minus Q by B. So we just put these values in this equation and get the result. Next we have an isolated metal sphere of a radius r is given a charge Q. The potential energy of the sphere is, we have these options. Move with the solution part. So we know that potential energy U is equals to half Cv square. U is equals to half 4 pi epsilon naught times R. Q by 4 pi epsilon naught R whole square is equals to Q square divided by 4 pi epsilon naught R. According to this, the correct option which we have is the option number 4. Next, charges plus Q minus 4Q and plus 2Q are arranged at the corner of an equilateral triangle of a side 0.15 meter. If Q is equals to 1 microcoulomb, their mutual potential energy is, we have these options. Let us move with the solution part. So U is equals to 1 by 4 pi epsilon naught Q1 Q2 by R1 plus Q2 Q3 by R2 plus Q1 Q3 by R3. We just put all these equations, all these values which is given in this question and get the result, which is minus 0.62. According to this, the correct option is option 3. Next, we have an electron of mass m kg. Here there will be no numerical data is given. And charge electronically E is given, E coulomb. Travels from rest through a potential difference of a V volt. The final velocity of the electron is in meter per second we have to calculate. The options are these which we have given. Now move with the solution criteria. So if the particle having some velocity, so kinetic energy must be equals to the potential energy of the particle. So if we put the value of half mv square, which is the kinetic energy, equals to the potential energy, which is EV, we get the value of a V, which is under root 2 EV by M. According to this, the correct option which we have a 3. Next question we have, two protons are at a distance of 0.53 10 to the power minus 10 meter. The potential energy of the system in electron volt is 13.6, 27.2, plus 6.8 and 20.4. Move with the solution criteria. We have a potential energy formula. We just put all these value in this formula, which is U is equals to 1 by 4 pi epsilon naught Q1 Q2 by R, and get the result, which is the 27.2 electron volt. According to this, the correct option which we have, that is the option 2. Next question we have, charges 6, 12 and 24 nanocoulomb are placed at the corner of a square of a side 10 root 2 centimeter. The charge that must be placed at the fourth corner so that the potential at the center of the square may be 0 is. The first we have option 42 Newton per coulomb. The second we have 36 nanocoulomb. Third we have a minus 42 nanocoulomb. And the fourth we have a 30 nanocoulomb. So here is a 42 nanocoulomb, not Newton coulomb. We have in solutions for this, V is equals to, we just take the summation of all these potentials and get the result after putting the value, which is Q4 is equals to minus 42 Newton coulomb, nanocoulomb. So according to this, the correct option for this question is option 3. Here I used a particular Newton coulomb, but that is not Newton, that is a nanocoulomb. Next we have a charge capital Q is placed at each corner of a cube of side A. The potential at the center of the cube is, we have an options are these. Let us move with the solution. So we know that the value of a V is equals to 1 by 4 pi epsilon naught Q by R. We just put all these value over there and get the result, which is V is equals to 4Q divided by root 3 epsilon naught A into pi. According to this, the correct option is option 3. Next we have a question. An infinite number of charges of equal magnitude Q coulomb but alternately opposite sign are placed along the x-axis at x is equals to 1, x is equals to 2, x is equals to 4 and so on. The potential at the point x is equals to 0 due to these charges will be, we have these options. So solution for this question is, potential at the point is a V, which is a Q by 4 pi epsilon naught into D. We just put all these value in this equation and it will be make a GP form. If we just put all the value in the GP formula, so we get the value of it, option 4. Next we have a question, electric charges and 10 microcoulomb plus 5 microcoulomb minus 3 microcoulomb plus 8 microcoulomb are placed at the corner of a square of a side root 2 meter. The potential at the center of the square in volt is, we have these options. Let us move the solution of this question. So we have the formula V is equals to 1 by 4 pi epsilon naught Q1 by R1 plus Q2 by R2 plus Q3 by R3 and plus Q4 by R4. We just put all these value over there and get the result. According to this, the correct option is our option 3. Next question we have, in a uniform electric field, the charge of a 3 coulomb experience a force of a 3000 Newton. The potential difference between 2 points 1 centimeter apart along the electric lines of force will be, we have these options. So the solution of this question is, F is equals to QE and the value of E is V by D. So we just put this value and get the value of V, which is 10 volt. According to this, we have the first correct option. Next question which we have, the capacity of a parallel plate condenser is a 10 microfarad without dielectric So dielectric constant is given of a 2 is used to fill half thickness between the plates. The capacitance is dash microfarad. We have these options: 10, 20, 15, 13.33. So let's move with the solution. We know that the value of a C is epsilon naught A divided by D minus T plus D by K if the dielectric constant is inserted. So C is equals to epsilon naught A by D. The value at that time 10 microfarad, T is D by 2 and K is 2. We get the value of the C is 13.33. According to this, we have an option. Fourth is the correct. Next, we have an oil condenser has a capacity of 100 microfarad. The oil has a dielectric constant too. When the oil leaks out, its new capacity is. We have these options. So, let us move with the solution part. C is equals to C prime by K. We put this value and get the result, which is a 50 microfarad. Next question we have a variable air capacitor has 11 movable plates and 12 stationary plates. The area of each plate is 0.00515 meters square and separation between the opposite plate is 0.001 meter. The maximum capacitance of the capacitor is, we have these options. Let's move in the solution part. So we have a C is equals to n minus 1 epsilon naught Ke divided by B. We just put this value over there and get the result, which is option 4, 292.2 picofarad. The next question which we have is the plates of a parallel plate capacitor are charged up to 200 volt. A dielectric slab of a thickness 4 mm is inserted between the plates. Then to maintain the same potential difference between the plates of the capacitor, the distance between the plates increases by 3.2 millimeter. The dielectric constant of this dielectric slab is, we have these options. So D is equals to T 1 plus 1 by K. We just put this value and get the result of a K, which is a 5. I hope you understand these kind of questions. Till that, this much we will solving and wait for the next class. Till that, every student take care of yourself.